Hey guys, so we are going to get started with today's lesson. So lesson 86, area of a circle. So please follow along in your book, starting on page 460, and we're going to go to we will work all the way to the top of page 462. So go ahead and start by opening up your book, and we'll get started. So, area of a circle. So some of you may have learned this before, but the main equation that you're going to be using to solve for the area of a circle is this equation right here. Area, which is A, equals pi r squared. So what does that mean? So A stands for our area. So that whole area, everything that fills up that circle. Pi, we all know pi, 3.14. And then r, what does r stand for? R is our radius. And then we square that number. So let's get started with example 1. So follow along in your book. So we can estimate the area of a circle drawn on a grid by counting the number of square units enclosed by the figure. So example 1, this circle is drawn on a grid. How many units is the radius of the circle? So I went ahead and made my own circle here. It's the exact same one in your book. A little bit off because they don't have a lot of features on this for me to draw. So here is my circle, blue circle. And inside we need to figure out how many units is our radius. So starting from our middle spot right here, that blue dot in the middle, we're going to go out to the outside. So the radius is half of our circle. So from the middle to the side. So I'm going to do the right side here. So we have 1, 2, 3. So 1 unit, 2 units, 3 units. And if I were to do that on all the other parts too, so 1, 2, 3, you're going to notice that all the way around you have 3 units from your center point all the way to the edge. So our radius, r, equals 3 units. So that's part A. So make sure you're following along and taking notes. And then estimate the area of the circle. So how do we get the area of our circle? Well, in this specific example, they are wanting us to count up the number of squares inside your circle. Let's see how this goes. Okay. So we have 1 up here, 2 here, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay. So 24 boxes inside there. So the reason I didn't count up these little spaces right here is because the majority of those spaces is not filled up. So if we look in our book here, so the solution section under letter B at the bottom of page 460. So it says to estimate the area of a circle, We count the square units enclosed by the circle. We show the circle again, this time shading the squares that lie completely or mostly within the circle. So that's what we just did here. We shaded all of our boxes that are nearly completely shaded. So where did I leave off? So we count 24 squares that are mostly shown inside that circle. We also have marked with dots that have about half of their area inside the circle. So that's the part I did not do yet. So with my red pen here, I'm going to put a dot inside all of the ones that are not completely shaded. So 1, 2, 3, 4, 5, 6, 7, 8. So we count eight such half squares. Since 1/2 of 8 is 4, we add 4 square units to the 24. And then we are able to get, so when we have 1/2 of the 8, whoops. So half of 8, so 8 divided by 2 equals 4. So that's going to be an extra 4 units that I can add to my total 24. So 24 plus 4 equals 28 units. 28 units. Okay. So I'm going to move on. So this is kind of just showing you what is inside of your circle. You're not going to be working with a lot of this out in life with a circle like this. Instead, you're going to be using this equation right up here. Area equals pi r squared. And that's what we're going to work on with some examples here coming up. So I'm going to pause real quick, get my board erased. So with this example, so example 2, we have a radius of 10 millimeters. So you're going to see a lot of examples like this when you're getting into geometry. So 10 millimeters. So if we're using our equation up here, area equals pi r squared, we are going to plug this 10 millimeters, which is our radius, into that r value. So when you guys are solving this out, you are going to take a equals pi, which equals 3.14, pi times 10 millimeters squared. Okay, so when I multiply that out, so I have 3.14 times 10 squared is going to be 100 millimeters squared, because I'm also squaring my millimeters, not just the number. You're squaring both your number and your units, millimeters squared. So that's when we're starting to get into volume now. And then once you multiply those two together, this one's kind of a nice one. All you have to do is move over your decimal place to the right twice, and you get an answer of 314 millimeters squared for your area. Okay, so that's a nice, easy one for our first example here. So area equals 314 millimeters squared. Okay, so go ahead and try example 2 on your own. So when you see pi, so for that example, you have a radius of 3 centimeters. So make sure in your answer, you should have a centimeters squared in your answer. So when you multiply it out, you have 3.14 times 3 centimeters, and then you're squaring that centimeters squared and your 3. Okay, so go ahead and try that example, and make sure somewhere on your paper you are writing down that area equals pi r squared. So this equation right here is very important. That's one that you're going to end up just memorizing because it's a really important equation. So area equals pi r squared, and make sure you remember that pi equals 3.14, about 3.14, okay? So go ahead and finish up your notes there, and go ahead and get started on your lesson practice, so A through E, and then all of the numbers as well. I think this one was odds, okay? So go ahead and get started there, and if you have any questions, let me know. Thanks, guys.